Afternoon, dear students, class 8. So, last time we did separation of solid mixtures. Separation of solid mixtures. So, solid mixture is homogeneous or heterogeneous. It can be both homogeneous as well as heterogeneous. But last time we learned about the method of separation of solid heterogeneous mixtures. So today we'll be doing separation of solid liquid mixtures. That means one of the component is solid and the other component is liquid. One of the component is solid and the other component of the mixture is liquid. For example, salt and water. Salt is solid and water is liquid. So salt water is an example of solid liquid mixture. Okay, let's see. Now there are actually 6 methods discussed in your book, but today we will be learning only 3 methods, and next class we will be learning another 3 methods. So today we will be learning 3 methods. They are sedimentation and decantation, filtration, then evaporation. So 3 methods today we will learn. And before doing this, I request you all, whenever you will be seeing this video, make sure that you are opening your book, page number 29, and then make sure that after seeing this video, you will draw the figure in activity 2, then figure 3.6 and figure 3.7. That is your homework. Okay, let's go through the things in detail. So, sedimentation and decantation. First of all, let me explain you what is sedimentation and what is decantation. Sedimentation is the process of settling down of suspended insoluble heavy solid particles in a solid liquid mixture when left undisturbed. So definition of sedimentation is there in your book, and what is the definition? The settling down of suspended insoluble heavy solid particles in a solid liquid mixture. In a solid liquid mixture when left undisturbed. For example, mixture of sand and water. Say there is a mixture of sand and water and you leave it undisturbed. You kept it in a glass and left it undisturbed. So after some time, what will happen? You will see that all the sand particles will settle at the bottom of the glass. So this process of settling down heavier solid insoluble particles at the bottom is sedimentation. So in very short way, if I have to say, then it is settling down of heavy solid particles at the bottom of the liquid is called sedimentation. Then those particles which are settling at the bottom, for example, if this is a container, and this, say for example, this container has water, and then here if you can see sand particles settling down. This is sand and this is water. Sand and water. Say for example, this is the example of solid liquid mixture. Here solid is sand and liquid is water. So sand here is called sediment. So what is sediment? The solid which settles at the bottom. The solid. This sand is settling down at the bottom. So this is sediment here. So what is sediment here in this mixture? Sand is sediment here. And why sand is sediment here? Because sand is settling at the bottom. So those insoluble, solid, heavy particles which settle at the bottom are called sediments. And the clear liquid above the sediment, the clear liquid above the sediment, here it is water. So the clear liquid above the sediment is called supernatant liquid. So what is supernatant liquid? What is supernatant liquid? The clear liquid above the sediment. The clear liquid above the sediment. So whenever you can try it at home, mix sand with water and put it in a glass and disturb it thoroughly. You can just stir it, then leave it for a while. So what will happen is when you are stirring, you may see the liquid is not clear. But after the sand particle settles down, you can see the liquid is clear. This clear liquid above the sediment is called supernatant liquid. And the sand which has settled down at the bottom is sediment. The process, whole process of settling down the heavier insoluble solid particle at the bottom is sedimentation. Okay, then sedimentation is always followed by decantation. Sedimentation is always followed by decantation. So what is then decantation? The process of pouring out clear liquid without disturbing the sediment. Now you got that the liquid is clear. The clear liquid has come out. That is supernatant liquid. And sediment is there. Now if you are pouring this clear liquid, this supernatant liquid into another container without disturbing the sediment, the process is called decantation. So what is decantation? Pouring of clear liquid without disturbing the sediment is called decantation. The process of pouring out clear liquid without disturbing the sediment is called decantation. So sedimentation alone is not the method of separation. Why? Because we are not separating out the mixture here. We are not separating out the component from here. We are simply we are settling down the sediment here in the case of sedimentation. But when we use the process called decantation, when we use another method that is decantation, then only we are separating liquid and solid. Then only we are separating liquid and solid. That's why sedimentation is followed by decantation. So you may get a question why sedimentation is followed by decantation. Because without decantation, sedimentation, this process doesn't become the method for separation. Doesn't become the method for separation. In sedimentation, heavy particle settles down. In decantation, the clear liquid that is above the sediment is separated from the sediment. So that's why sedimentation and decantation together is a method for separation. But individually, they are not the method for separation. Together, they are the method for separation. Now let me see on which principle does this method works. So for using this particular method, what type of mixtures we need? So solid component must be insoluble and heavier than the liquid component. So what type of solid liquid mixture we need, or what type of solid liquid mixture we can separate by using sedimentation and decantation? The mixture in which solid component is insoluble, in which the solid component is insoluble. Not only insoluble, it has to be heavier than the liquid component. It has to be heavier than than the liquid component. If it is lighter, it cannot settle down. If it is sawdust and water, for example, sawdust and water is there. So for sawdust and water, can we use sedimentation and decantation? No. Because sawdust never settles at the bottom because sawdust is lighter than water. That's why for separating sawdust and water, we cannot use this method. We cannot use this method. This is used only when solid component is insoluble and heavier than the liquid component. So example for this is mixture of sand and water. Mixture of sand and water. If the mud is heavier than the water, then that also can be separated. That means whatever mixture it is, the solid has to be insoluble and heavier than the liquid. We can use this method. Okay. Hope you are clear with this. And you will do activity figure under activity number 2, so that it will be very much clear for you. Now next, filtration. So before telling how to separate the mixture, solid liquid mixture using filtration, let me know first what is filtration. The process of separating insoluble solid liquid mixture by allowing it to pass through a filter paper. That word is the definition in your book. So the process, it is the process. Filtration is the process in which what happens? In which solid, insoluble solid is separated. Insoluble solid is separated from solid liquid mixture. From solid liquid mixture. How to separate then? This here also we are separating. So in this case, what we use? We use filter paper. What we use? We use filter paper. So in filtration we use a filter paper. So filtration is the process of separating insoluble solid from solid liquid mixture by allowing it to pass through this filter paper. By allowing this to pass through this filter paper. Now, whatever liquid we are getting, okay, after filtration, whatever liquid comes out of the filter paper, whatever liquid is collected through filter paper, passing the mixture through filter paper, whatever liquid we are collected, that liquid is called filtrate. That liquid is called filtrate. So what is filtrate? Filtrate is liquid that passes through filter paper. Filtrate is the liquid that passes through filter paper. And you can see something on the filter paper. You can see something on the filter paper. And that something that is left on the filter paper is insoluble solid particle. Insoluble solid component. So this insoluble solid component is residue. So what is residue then? Residue is the insoluble solid component left on the filter paper during the process of filtration. Is residue. Okay. Now let's see on which principle does filtration works. So this filtration, for using this process called filtration, for using this method called filtration, solid component must be insoluble in the liquid. Either it is heavier or lighter, doesn't matter. Either it is heavier or lighter, doesn't matter. So for heavier, it is easy to use this only, sedimentation and decantation. For heavier. But we can use filtration also. But if we can do by using this process, in which we do not need a filter paper, so this will be the perfect method. But we can separate solid liquid mixture in which solid is insoluble, either it is heavier or lighter than the liquid, by using filtration. So in filtration, only one thing is that solid has to be insoluble. solid has to be insoluble. Whether it is heavier or lighter doesn't matter. But for sedimentation, solid has to be insoluble and heavier than the liquid component. That is must. But in filtration, it has to be insoluble only. Doesn't matter whether it is heavier or lighter than the liquid component. So this is the principle. Then example, chalk and water. Chalk and water. So chalk 100% doesn't settle down. It suspends. Though you allow it to settle, though you keep it undisturbed for 1 hour, 2 hours, but then also you can see some of the particles are suspending, hanging around in the liquid. So that means it is not completely settled. So chalk and water, the mixture of chalk and water. In this chalk and water mixture, chalk is solid, water is liquid. So solid liquid mixture. So what we do here in this process, what we do is we just take a filter paper, and as in figure 3.5 you can see how to make cone out of the filter paper. How to make cone out of the filter paper. So this conical filter paper is kept inside the funnel, and then the funnel is tilted inside a beaker, and through this funnel, which is fitted with a filter paper, you pass the mixture, solid liquid mixture, and then you can see that the clear liquid will start collecting in the beaker. This clear liquid that we are getting in the beaker is filtrate, and the chalk powder that we are getting in the filter paper, chalk powder on the filter paper, is residue. In this way we are separating solid from solid liquid mixture. Solid and liquid both are separated. So solid and liquid can be separated by using filtration, provided solid is insoluble in the liquid. Provided solid component is insoluble in the liquid. Then third one, evaporation. You are very much familiar with this method, this process, evaporation. So what is evaporation? The process of converting liquid to vapor. The process of converting liquid to vapor by allowing it, by exposing it to air or by heating. Because evaporation takes place at any temperature. Evaporation takes place at any temperature. Evaporation takes place in Ladakh also. Though it is raining, though it is very cold, though the temperature is minus degree Celsius, -2, 0 degrees Celsius, but then also evaporation takes place. That means evaporation takes place at any temperature. So if you expose the mixture, solid liquid mixture, in the air, okay, then also evaporation takes place. Then also you can see liquid converts to vapor, but the process will be really very slow. And this can be done by heating also. By heating also liquid can be converted to vapor. So the process in which liquid is converted to vapor by exposing it to air or by heating is called evaporation. So how this process, evaporation, is used in separating solid liquid mixture? Let's see. So for this also we will be drawing figure 3.7. Figure 3.7 you will draw. Okay, then this one is a heterogeneous, solid liquid heterogeneous mixture because here solid is insoluble. That means it is not uniformly mixed, and we can see through our naked eyes. It is not uniformly mixed. So this is solid liquid heterogeneous mixture, and this is also solid liquid heterogeneous mixture because it is insoluble. Solid is insoluble. So if I ask you for solid liquid heterogeneous mixtures, which of the methods can be used to separate its components, then you can say sedimentation, decantation and filtration. But if you say evaporation, it will be wrong, because evaporation is used to separate homogeneous solid liquid mixture. Homogeneous means solid is soluble in liquid. Solid is completely dissolved in liquid. It is uniformly mixed throughout the liquid. So, homogeneous solid liquid mixture can be separated by using evaporation. But this homogeneous solid liquid mixture cannot be separated by using this process. Okay? In which only solid is recovered. Now, by using this process, we cannot get both the components. We can get only solid components. We can get only solid components. We cannot get liquid component because liquid component will escape out in the form of vapor. Liquid component will escape out in the form of vapor. So, we can only get solid component. We can recover solid component only. Okay. Now, for example, salt and water. So, if I dissolve salt in water, then I can see that salt is completely dissolved in water. Salt is completely dissolved in water. So salt and water forms a homogeneous solid liquid mixture. And if I pass it through filter paper, what will happen? Nothing will be there in the filter paper. Still, whatever I am getting, that is called filtered. Again, there will be salt and water only. So I will not be able to separate salt from water using filter paper. Or if you settle it for a long time, then also you cannot see solid, that is salt settling at the bottom. That means this process cannot be used for homogeneous solid liquid mixtures. Okay. So evaporation, that means what is the principle on which or what kind of salt, what kind of mixture, what kind of solid liquid mixture can be separated by using evaporation, that is homogeneous solid liquid mixture. But we cannot get both solid as well as liquid. We cannot recover solid as well as liquid from this mixture. We can simply get solid only, liquid will get escape. Liquid will escape out. So salt and water. Now salt and water. The very much easy, very much common example for this is the salt, the table salt, the common salt that we are taking daily we are getting it by the process called evaporation. Seawater, from seawater. Seawater is poured somewhere and it is exposed to air, then water gets evaporated and salt is left. Salt is left. So by using this process, or if you want to do at home, what you can do is dissolve 1 spoon of salt in water and start heating it until and unless whole of the liquid get evaporated. Or until and unless all the liquid get evaporated. Until and unless all the liquid converts to vapor. Then you can see something left in the container, and that is salt. So this way we can separate solid liquid homogeneous mixture by using the process called evaporation. And my dear student, I have already said you homework. Some of the questions will also come with this video only, some objective questions that you will do seeing this video. But in your exercise copy, you will be doing this homework, that is, draw figure 3.5, 3.6, 3.7 and figure from activity 2. Activity 2. Okay.